So in the last video, we talked about the metric system and how to convert between different prefixes using the same base unit. And we'll do that a little bit more today to some extent, but we're also going to talk about how we can convert from the metric system to English standard units, or the units, again, that we're more familiar with today, or vice versa. And we're going to use something called dimensional analysis. Now, guys, I'm going to be honest with you. Some of these conversions you can do in your head. Some of them you can just type two numbers in on the calculator, you know exactly what to do, you press enter and you get the correct answer. But I'm going to warn you from the very beginning. If you do not use the setup for dimensional analysis for every single problem where you have to convert from the metric system to English standard units or the other way around, if you do not use the method, again, that I am fixing to show you, you will get no credit. Dimensional analysis helps convert between different units. And let's go ahead and look at the way or the fundamental structure of a dimensional analysis problem. You deal with unit cancellations. So we're going to start with what we're given. The only thing in any word problem or any math problem that you can start with is what you're given. And you'll see that in some examples. You're going to put the given unit again on the denominator. So you're going to go given unit times, and then on the top of the next step of the problem, the desired unit, and then again on the bottom, the given unit all over again. Here's what happens. If you have the same unit, now this is understood to be at the numerator where this red line is. And if you multiply the same thing again on the denominator, it's going to cancel out. And that's going to leave you your desired unit. That's dimensional analysis. Whatever unit that you're wanting to get rid of, that you're wanting to convert into something else, if it's in the numerator, in the next step, simply put it on the denominator and that cancels it out. Guys, it's kind of like saying you've got 5 times 1/5. You have this on the numerator, this on the denominator. Guess what you can do? You can cancel them out and then you get the answer. So now let's go ahead and see if we can apply this to some chemistry or some science problems. Yeah, okay, really not. We're not going to do chemistry or science problems a whole lot here. We're going to do just some basic dimensional analysis. All right, so you're going to look for cancellations to get to the desired unit. So it's kind of like a puzzle or a mind map. And I hope you don't see this as like, oh, this is hard because it's math, or I've never seen this before, or this setup looks confusing. Like, don't look at it from that mindset. Look at it from the perspective of, hey, this is a puzzle. Can I solve it? Here's our first dimensional analysis problem. And again, guys, we're just converting. How many pennies are in $65,000? Wouldn't that be nice to have right now? Again, guys, the only thing that you can start with is what you're given. And the only thing that you're given in the problem is $65,000. So let's just rewrite that, okay? We've got $65,000. And so our current unit that we're in, so our current unit is dollars. And our desired unit is just simply a cent. So we're going to do that setup. And we don't want dollars anymore. We want to go to cents. And remember in the previous slide, I told you that, well, if you want to get rid of a unit, in the next step, you put it in the denominator, right? So every time you see one of these vertical bars, right, that means that whatever's to the right of it here is the next step. So right here's where we're going to write the next step. So we want to get dollars in the denominator so they cancel out. And we can put our desired unit on the numerator, as you saw in the previous slide. So our desired unit is the cent. It doesn't look like the cent symbol, but you get what I mean. So now we have to think about what to actually put by the dollar sign and the cent sign. And don't overthink this, because we know, common knowledge, that $1 is equal to how many pennies or how many cents? 100, right? And guess what happens? You've got your given unit that you want to get rid of, both in the numerator and in the denominator. So that means you can cancel these out. And you're left with your desired unit. So we're actually done setting up the problem, and now we can just do the math. So here's how you solve it. You're going to multiply the numerator straight across. So we got 65,000 times 100. So again, what is 65,000 times 100, right? This is where you just move the decimal over a few times. 65,000 times 100 is a big number. I should have shortened this down just a little bit before I did the problem, but anyway. All right, so we're just going to multiply the numerator straight across. 6,500,000. So this is your numerator multiplied straight across. Now we've got to multiply our denominator straight across, and that is simply over 1. So that simplifies to 6,500,000. And what unit are we in again? We're in cents because we canceled dollars out. And that's dimensional analysis. Let's do another problem. If my car takes 2.5 gallons, so and you see the word quart, so we're dealing with empirical units. If my car takes 2.5 gallons of oil per oil change, in other words, it burns 2.5 gallons of oil per oil change, which is bad, how many quarts of oil must I buy? And guys, really, it doesn't really matter. Like, don't get caught up by the problem. Who cares? If you're not into engines and changing your oil, who cares? What's the only piece of information you're given in this entire problem? Well, it's 2.5 gallons. So let's rewrite it. The only piece of information that you're given is 2.5 gallons. So this is your given unit. So given 2.5 gallons. Your desired unit, it says quarts. So we know what we got to do. In the next step, gallons, which is our given unit, has got to go on the bottom. Why? Well, so it cancels out because we want to get it in terms of our desired unit, which is the quart. So we go ahead and write quart here on the numerator, and we can go ahead and cancel out our units. But now the question that students love to ask is, well, how do I know what goes here and what goes here? And again, you probably know this. You probably know that there are 4 quarts in 1 gallon. If you didn't, well, you can just Google it, right? So are we in our desired unit of quarts? We sure are, because gallons got canceled out. So now let's just do some basic math here. We're going to multiply our numerator straight across. So we got 2.5 times 4, right? And then, you would do the same thing and you would multiply your denominator out straight across. But anyway, 2.5 times 4 is equal to 10. And then you've just got 1 on the denominator. So that is equal to 10. And what unit are we in? Quarts. And you've got to write what unit you're in at the end of the problem. If you just wrote 10, you're wrong. It's 10 quarts. Because how do I know you didn't do the math wrong or you goofed up? I mean, think if you said 10 gallons, you did the math right, but unfortunately you missed the entire point of unit conversions, and that's totally wrong. So you've got to specify what unit you're in every single time. Now this is a question here because milliliter is the metric system and gallons is the old standard system of units. But again, it doesn't matter. What's the only piece of information you're given in this problem that you can start with? Well, 7,500 gallons. Okay? So we'll do our little setup here, but let me write given. That's 7,500 gallons. And our desired unit, and I recommend you do the given and the desired every time, is the milliliter. Okay? Here's the problem though. Do you know how many, well actually let's do this first. We got the milliliter. Remember in the previous unit I said milli was a prefix and liter was the base unit? Right? Remember, liter is your base unit. Just like gram is a base unit for mass. And milli is the prefix. And again, that just shows whether or not it's large or whether or not it's small with respect to the base unit. Right? So what we got to find out first is, well, how many gallons are in a liter? Or in other words, we got to get it in terms of our base unit. So anyway, none of that really matters at this point. Our given unit is in gallons. It's in the numerator. In the next step, we got to put gallons in the denominator just simply so we can cancel out and get into another unit. The unit that you want to get it in terms of is the base unit, which is the liter. So let's go ahead and put L for liter right there. I'll go, even though it's not a capital L, I'll go ahead and well, I guess it is. I'm going to write L for liter. But what we have to do now, and I don't, to be honest with you, I had to Google this. There are 3.785 liters in 1 gallon. So 1 gallon is 3.785 liters. Let me make that a little bit better. Let me make that just, that's going to be too big. 1 gallon, sorry about that, y'all. It's all good. 1 gallon is 3.785 liters. But this is a two-step problem here. Because we're in, what unit are we currently in? We're currently in liters, right? We are currently in liters because gallons canceled out. But is our desired unit liters? No, it's milliliters, right? And so the third step of the problem, look, you could write liters here, and then that would cancel out, and you could just have your final unit of milliliters, and you'd be good to go. Or we can just go back, right? We can just go back. So let me clean this up. When I say back, we can go back to a previous video, and you just know how to move the decimal over a few places, okay? So what I want to do right now is I want to clean this problem up. We've got 7,500, and we got a multiplier numerator straight across. So we're going to have 7,500 times 3.785, and that gives us 28,387.5 liters. Okay? 28,387.5 liters, but we want to go to milliliters. So let's visit back to a previous slide here. And we are in liters, and we want to go over to milliliters. So as you can see, we go over 1, 2, 3 places to the right. And so we're just going to move our decimal over 3 places to the right. So we've got 28,387.5. And that is in liters, and we want to go to milliliters. So we're going to move our decimal over 3 places to the right. So we've got to move it over 1 place. Right there. Let's move it over another place. We got another 0. And let's move it over 1 more time. Right there. So now it turns into, let me write over here, 28,387.500. So 1, 2, 3, comma, 1, 2, 3, comma, 28,387,500 milliliters. And that would be how you would work this problem right here. Again, we just simply said, well, let me find this slide. We converted gallons to liters. Again, we're going from English Standard to the metric, so we need to use dimensional analysis. But now that we're in liters, we can just go back to that little chart and move it over 3 places to the right to milliliters to get our 28,387,500 milliliters. All right? How many hours are in 54,759 years? Well, this looks like kind of a daunting problem, but it's not. Here's what I mean. Well, the only thing you can start with is 54,759 years. So, what unit do we want to get into? Well, hours. So our given unit is in years, and our desired unit is hours. So automatically, what unit goes on the bottom so we can cancel? Years, right? So years are gone, and we want to convert to hours. But the problem is, do you know in your head how many hours are in a year? Now, yes, I know you can Google it, but let's just do this based off of common knowledge. I have no idea how many hours are in a year. But I'll tell you this, I know how many days are in a year. I know that 1 year is 365.25 days. Now, if you left the 0.25 off, that's fine. What unit are we in now? We're in units of days, right? Absolutely. But do we want days? No, of course not. We want hours. So what do I do with days in the next step if it's in the numerator so I can cancel it? I put it on the bottom. So, what's another easy conversion? Well, I know how many hours are in a day, right? I know how many hours are in a day. So I'll put hours on the top. So days will cancel because you have it in the numerator and the denominator. I know 1 day is equal to 24 hours. And now I'm in the desired unit of hours, right? So now all we do is multiply the numerator straight across and the denominator straight across. This is going to be a big number because we got 54,000, and you would expect it to be a big number, by the way. It makes common sense. 54,759 times 365.25 times 24. And then we're going to multiply our denominator straight across, and that's just 1. And so when we do that, I'm obviously going to have to use a calculator for this. 54,759 times 365.25 times 24. So this is 480,017,394 hours. And again, don't forget to write the final unit. Let's do one more problem. How many moles of carbon are in 75 grams of carbon? Now, you've heard of gram, but you're like, a mole? That's a furry little creature, or some annoying thing that goes on. I get, sometimes on my skin. Again, I don't care. I don't expect you to know what a mole is. It doesn't matter right now, because again, you start with what I always tell you to, and that's what you're given. The only piece of information that you're given in this problem is 75 grams of carbon. Okay? Now, our given unit is in grams. Our desired unit, which you'll learn about the mole in a few more lessons. All right, our desired unit is the mole. But again, guys, here's what you know. We don't want grams. We want moles. So I've got to put grams of carbon on the bottom, on the denominator of the next step, just simply so I can draw a line through it and cancel it. Now, I gave you a hint. I said 1 mole of carbon, so I can say 1 mole of carbon is equal to its molar mass, or the mass of carbon on the periodic table, which is 12. So if you look on the periodic table, you'll see the number 12 below the chemical symbol for carbon, right? You would see the number 1 underneath the chemical symbol for hydrogen. For helium, you would see that it weighed 4 grams, so on and so forth. And so, again, that doesn't matter, though. I gave you what you start with, and I gave you the hint for the conversion factor. So now we're going to multiply the numerator straight across, which is 75 times 1. And we're going to multiply the denominator straight across. By the way, you can always assume the number 1 goes here. I'm sorry I haven't said that sooner. Divided by 12. So we got 75 times 1 divided by 12, and that comes out to be 6.25. But what unit are we in? Moles. of carbon. And that, my friends, is dimensional analysis, sometimes using the metric system. Well, you know what, by the way, actually, right before I end this video, I want to point something out over here, okay? I could have easily finished this conversion without having to go back to that little chart where I jumped over 3 places to the right. I could have said 1 liter is 1,000 milliliters, because 3 places, think about it, 3 places is just adding 3 zeros, so it's a factor of 1,000. And that still would have given me this number, and it still would have been in the correct unit of milliliters. I just wanted to point that out, okay? All right, have a good day.